Hello. I'm going to give you a hint on number 97. It's a hard problem. Number 97 asks you to show that both of these formulas are valid. Now, there's a bunch of different ways to do it. One way would be to take the derivatives. Again, there's going to be some algebra involved. Another way is to show it directly. And this is a hint. So you can ignore the C's, and you'll see why if you go through this, but just show that this is equal to this by algebra. And I would start here. I'd write things in terms of sines and cosines and manipulate these until you end up with this over here. It's doable. There's a couple of tricks involved, so it's a little challenging. The third way is just to integrate secant x du in two different ways. And that's what I suggest. And I also want to point out there's an extra credit that's due Tuesday, 9/9. And what I want you to do is do all three of these, this way, and this way, both carefully and neatly. So I don't want a lot of crossouts and things like that. So if you can do that, you'll get some extra credit points. Okay, so here's the hint. Well, first of all, review. In example 9, we integrate, there's the formula for integrating secant, and that should be an x. And I may do this in class, we'll see. But this seems to come from out of absolutely nowhere. It's kind of a real, where did this come from? So what you do, but by the way, what you're doing here is you're taking secant x, you can check in the text to go over this, you're multiplying creatively by 1, secant x over tangent x, and you get this. So, well, why does this work? Well, let's pick the bottom for u. And again, if you're not sure what to pick for u, you look for something in its derivative, and you see the derivative of sectan, derivative of tan is sec squared. So we do that, and we get derivative is secant x tan x plus secant squared. And that's exactly this. So this works out perfectly. This is going to be the integral of, I'm going to just switch things around, secant x tan x plus secant squared x. So I just switched that around to make it more friendly. Over u dx, well, that just becomes, that's my du, if you look right up here. This is the natural log absolute u, as we saw earlier, and this is going to be equal to the natural log of secant x plus tan x plus c. So that's the first formula. We showed that one. Now we need to do that one. My hint is to try this instead of this. In other words, this should be over itself. And then if you do that and go through it correctly, you'll get this. And I think it's the easiest of these three ways. Now, a little bit of background to this. I have no idea where this came from. I'm an historian of mathematics, and the history doesn't record the first person to figure out most integral formulas. Now, you learn to do tricks like this the more math you do. Like if I gave this to, I think a math prof who never saw this before, they'd sit down for a while and try a bunch of things, and it would be reasonable for them to come up with this. But for you all, if you haven't done this kind of thing before, I think you could sit down with this for days and weeks and not get an answer until you think to do something like that, which again doesn't occur naturally. So one answer for where this comes from is that when you do a lot of math, creative multiplication by 1 is something that's used over and over again. Now, the second way is that maybe somebody worked with this, had to take a derivative of that at some point and realized, oh, that just simplifies to secant. And so when they had to integrate secant, they were able to recall that. I don't know. That's all speculation on my point. As I said, that stuff gets lost in the mists of history. But anyway, don't worry about not being able to do this on your own. I mean, you can certainly follow the steps, but don't worry about not being able to come up with stuff like this on your own. It's hard to do. But somebody did it at some point, and I admire whoever that was. Thanks for your time.